Hello everyone, good morning all of you. Welcome back to the video lecture series. So dear friends, we are discussing the analysis of food in our analytical chemistry paper number CHA 393. Up to this we have covered our first 5 chapters. Now we are going to see the sixth chapter, lesson number 6, and that is analysis of proteins. Last time we have covered the analysis of lipid material. Okay, now proteins. First topic is the introduction. So proteins, these are basically nothing but complex nitrogen containing organic compounds. Proteins are the nitrogen containing organic compounds which are basically made up of alpha amino acids. Dear friends, we know that the basic structure of all proteins is made up of amino acids, and these amino acids are combined or they are bonded together by a peptide bond, okay, or amide bond. We know that the peptide bond is NHCO. So all these amino acids are joined together by a bond. That bond is known as NHCO. This bond is called as peptide bond, okay, and this is the building blocks. All these amino acids are the building blocks of all these proteins, and these proteins are the essential part of all living organisms, including plants, animals, human beings, microorganisms, etc. Okay, these proteins, as they are organic compounds, are consisting of carbon, hydrogen, oxygen, nitrogen, sulfur are the main elements present in these proteins, and hence the analysis of these proteins is very essential for the health point of view, for the pricing point of view, and all remaining etc. Okay, so that's why the analysis of proteins is the unavoidable part of the food analysis. As we are going to study, and we are studying this food analysis, so this protein analysis is one of the essential part of this food analysis, okay, and that's why there are several methods have been developed during these last 100 or 200 years, okay, for the food analysis, and due to these the recent advancements have been put forth by the different group of scientists in different countries for this analysis of proteins in foods. Okay, now next point is importance of analysis. What is this importance? Why we have to do this protein analysis? Okay, the first point is regarding health and nutrition value, nutritional labeling. We know that whatever we buy, whatever we purchase in a packaging material, okay, in shops, in the market, all that packaging material have the labels, food products, okay, mainly they have label. The label is consisting of the nutritional information, amount of energy we are getting from that product, then proteins, carbohydrates, fats, non-fats, etc. All this information is necessary, which is given mandatory information by all the governments in all over the world. So that's why this is one of the important condition or important part why we should do a protein analysis. Okay, then the second point is pricing. Now what is this pricing? Pricing is related to the because in some food products the price of that food product or the cost of that food product is directly related to the protein content value of that food product. Okay, for example, dairy products, most of the dairy products, they are sold in the market on the basis of protein contained in that food sample. Okay, so for example, milk or cheese or fats, sorry, not fats, milk, cheese, and your cereals, mainly cereals that we used in our diet, they are mainly based, their price is mainly based on the protein content in the sample. Okay, so that's why the pricing is one of the important reason for the analysis. Then the third one is functional property investigation. Functional property means whatever the number of proteins, different types of proteins present in the given sample or food sample or given product, but a specific protein is essential for the specific property of that product. For example, glutamine is the protein which is essential in the wheat flour. Wheat means gehu, the grains from which we are making chapatis or rotis, okay, that is called as wheat. And that wheat flour, for making that wheat flour or for making that atta, okay, so glutamine protein is essential for making that atta or wheat flour, okay. So the price or cost of that wheat flour or that wheat is directly dependent on the presence of glutamine protein in that wheat, okay. So that's why such properties are related to the food sample. So investigation is necessary to analyze the food sample in this regard. Or in some cases casein. So casein is present in our milk. Milk is containing protein known as casein. This casein protein is essential or it is important for the coagulation in the formation of cheese, okay. So that's why casein investigation is necessary. So that's why in other words we can say that casein protein analysis is necessary or protein analysis is important. And the fourth one is biologically activity determination. Some proteins are having specific biological activity in the metabolism properties of this living organisms, okay. So these are the main important aspects of the analysis of proteins. Then methods. This is the important part behind this chapter. Methods. Number of methods have been put forth by the different group of scientists in all over the world for the protein analysis, okay. Now this protein analysis is done in all over the world by a simple and a routine traditional method known as Kjeldahl method. So Kjeldahl is the name of scientist who discovered this method, and this method is known to us by his name, Kjeldahl method, okay. This is one of the oldest and traditional method for protein analysis, okay. Now what is this process actually? So the principle of this Kjeldahl method is, in this case, proteins which are present in the food sample, they are digested with the help of sulfuric acid, that is HTSO4, and a catalyst. So proteins are digested. We have a food material and the food material is get digested. So food material is containing proteins and these proteins are get digested in sulfuric acid in presence of catalyst. And then in this case, in this digestion process, the total organic nitrogen present in that food sample is get converted into the ammonium sulfate. By the action of sulfuric acid, okay. So total nitrogen, whatever it may be the nitrogen present in different forms of compounds in this food sample, that is converted totally into the ammonium sulfate. Then this is the acidified and digested food material, digested proteins in our sample. So we have to neutralize it. So for neutralization we must use a alkali or a base. So alkali is generally used, and along with that alkali, sodium thiosulfate is added and it is distilled into boric acid solution. After neutralization, it is distilled into boric acid solution, and then borate ions are formed. We will see later how these borate ions form in our calculation and reaction part. So borate ions are formed in these reactions, and these borate ions are titrated with standard acid. These borate ions are titrated with standard acid, and this acid is hydrochloric acid. Okay, and so what is the result of this Kjeldahl method? The result is the total crude protein content of the food sample is investigated, is determined. Okay, so total crude protein is a concept of so general total protein content of that food material is identified or determined by using this Kjeldahl method. So this is the very simple principle of this Kjeldahl method. Okay, now what are the general steps, what are the general procedures, general steps, or we can say the procedure for Kjeldahl method? So friends, here there are mainly 3 steps that we have to follow in this Kjeldahl method. The first step is digestion. So what is by digestion? This digestion term is not related to the digestion when we take a food and our digestive system digests our food. That is the different. The same way is there, the principle is same. When we say that our food is get digested, so the hydrochloric acid, dilute hydrochloric acid, which is present in the our stomach, okay, it is acted upon that food and it is get digested. Okay, means whatever the food components present in our food that we are eating, okay, it is get digested in the our body fluids. Okay, so acid action is important here. In our body, hydrochloric acid is doing the work, and in this case sulfuric acid, that is HTSO4, is doing this work. So whatever the protein content in our food sample, all this protein content, when it is reacted with concentrated sulfuric acid, and when we give a heat, okay, that protein content is converted into the nitrogen, organic nitrogen. Okay, and this process is done in the presence of a catalyst. Okay, so different catalyst can be used here. Previously potassium permanganate were used in the past, but after all some copper, some other metal catalyst have been used, okay, for this digestion process. So simple, a flask is taken, and in that flask our food sample is taken, and that food sample is heated. Along with that, our sulfuric acid and a catalyst, it is get heated. Okay, and after heating, after distilling, after refluxing, the protein content, proteinous nitrogen is get converted into the organic nitrogen. Okay, and as we have nitrogen atom here, so the nitrogen, organic nitrogen, is converted into ammonium ions, NH4 plus ions, and these NH4 plus ions, they combined with the sulfate ions that are present in the sulfuric acid, okay, and ammonium sulfate, a non-volatile ammonium sulfate, is formed. So this is the process of first step, that is known as digestion. Okay, the next step is neutralization and distillation. First of all, we will see the chemical reactions that occur in the digestion process. See here, see the reactions in neutralization and distillation. So okay, there are no reactions here. I don't written here. The reactions that are happening in this digestion are like this: nitrogen, in short we call it as a proteinous nitrogen, present in the food sample. We heat it in the presence of sulfuric acid and catalyst, and we do heating. It is get converted into NH4 plus ions. It is get converted into NH4 plus ions, and these NH4 plus ions combines with sulfate ions from the sulfuric acid, and they are converted to ammonium sulfate, NH4 twice SO4. Okay, so this is the reaction that is occurring in the digestion process. Now the next step is the neutralization and distillation. Now what is neutralization? When we have acid, we have to add a base, and the reaction between them is called as neutralization reaction. So that's why we have acidic solution here, and hence we have to add a alkali or base. Okay, so sodium hydroxide, a strong alkali, is needed to neutralize this sulfuric acid solution. Okay, so this ammonium sulfate which is formed in this digestion first step, it is reacted with this alkali sodium hydroxide. In this case, this ammonium NH4 plus ions are converted into free ammonia. They are converted into free ammonia, and sodium sulfate and water it is formed. Sodium sulfate and water is formed. Okay, now here this ammonia NH3, this ammonia is then treated with boric acid S3BO4. Okay, so second step name is neutralization and distillation. So we added neutralization. For the neutralization we added sodium hydroxide. This sodium hydroxide is converting this ammonium sulfate into a ammonia and Na2SO4 and water. Okay, so this ammonia gas or ammonia molecule is get treated with this boric acid. This is a base. Ammonia is a mild base. It is get treated with the boric acid S3BO4. So boric acid is a proton donor. So one of the protons get donated from this boric acid to this ammonia. It is get converted to ammonium ions, NH4 plus ions, and a counter ion is the borate ion, that is H2BO3 minus. This is called as borate ions. Once these borate ions are formed, the next step is the titration with sodium thiosulfate. Titration with sodium thiosulfate, and this is the old method. In sodium thiosulfate were used. Now in recent days, because in old method this sodium thiosulfate is used, because in the second step they were using potassium iodide and iodate ions. Potassium iodide and iodate ions. So iodine is generated in this neutralization step, and hence the liberated iodine was titrated with the sodium thiosulfate. Okay, that process and reactions that we have already seen in the lipid analysis. Okay, but in the recent method, new method, this new titration is done. The borate ions are titrated with the standard hydrochloric acid solution. Okay, so H2BO3 minus plus H plus, the reaction between this hydrochloric acid and this boric acid, borate ions, to form again this boric acid S3BO3. S3BO3 is nothing but BOH thrice. BOH thrice. This is the formula of boric acid S3BO3. Now the calculation part. So the calculation part is very simple again. Why we are titrating this borate ions with this H plus, that is acids, hydrochloric acid solution? Because the concept is such that whatever the hydrochloric acid, whatever the volume of hydrochloric acid, standard hydrochloric means the concentration of this hydrochloric acid we know known to us. The hydrochloric acid, the amount of hydrochloric acid required to neutralize these borate ions, it is equivalent to the number of ammonia molecules formed. Number of ammonia molecules formed in this reaction, and number of ammonia molecules formed, they are equivalent to the number of nitrogen atoms present in the food sample. Okay, or sorry, number of nitrogens. Instead we can say the moles of nitrogens present in the food sample. So this is the corollary between the HCl, borate ions, ammonia and nitrogen and protein. Okay, this is the sequence. HCl equivalent to borate ions are equivalent to ammonia reaction. Okay, this reaction, this ammonia reaction is related to the ammonium sulfate, and ammonium sulfate is related to the nitrogen atom present in the total nitrogen content present in the food protein, and it is directly related to the total protein content of the food. So this is the relation between all these chemicals and stoichiometry. So moles of HCl is equivalent to moles of ammonia. Okay, acid base reaction is there, that is equivalent to moles of nitrogen in the sample. Moles of nitrogen in the sample, it is related to the amount of protein present in the food sample. Now the percentage of nitrogen is equal to normality of HCl solution into corrected acid value. So this corrected acid value is nothing but volume of that acid required for sample minus volume of acid required for blank solution. This difference is known as corrected acid value. So normality of HCl into corrected acid value divided by weight of sample in gram into 14 gram nitrogen. 14 is the atomic weight of nitrogen. 14 gram of nitrogen divided by its moles into 100. Why it 100? Because we are taking in percentage. Okay, so this is the percentage of nitrogen. Now on an average, the food samples, the food materials are having 0.16% nitrogen of the total weight. 0.16% of the total weight. Okay, of the 0.16% protein of the food sample. Okay, so that's why percentage of protein can be calculated from this percentage of nitrogen by using a formula %n divided by 0.16. Okay, as it is percentage means 100 divided by 0.16. Okay, you will get the 6.25. Okay, so that's why this is the another multiplying factor, that is percent protein can be calculated by using formula %n divided by 6.25. Okay, so this is all about the principal procedures, reactions and calculation part of this Kjeldahl method. What are the advantages? The advantages are very superior, that this is one of the cheapest method, very cheaper or inexpensive method for the protein and nitrogen content analysis. Then this is giving accurate results. Then the third one is it can be modified to the microgram nitrogen content or microgram protein content of the food sample. Then there are some disadvantages of this Kjeldahl method. The first one is it measures, as it is a vigorous reaction between the sulfuric acid and the nitrogen content of the protein content of the food sample. So that's why it measures the total nitrogen content. It measures the total nitrogen content of the food sample. So this is generally not required. Okay, we are requiring the nitrogen content belonging to the protein part of the food sample. Then it is time consuming. This process requires a lot of time. Then corrosive reagents are handled. We have to use here because concentrated sulfuric acid is very corrosive in nature, and hence this is the one of the disadvantage or drawback of this method, that corrosive reagents such as sulfuric acid we are going to use here. Okay, so this is all about the first method, that is known as Kjeldahl method. I think this is sufficient for today. Rest of the things in this protein analysis we will see in our incoming video. Okay, thanks for watching this video. Have a nice day.